Okay guys, let us look at question 6 from November 2022, Physical Sciences paper 2. Let's not waste any time, let's tackle this question. Question 6, this is chemical equilibrium. It says carbon, which is in solid state, reacts with sulfur, gaseous phase, according to what? To the following balanced equation. Let us look at our equation here. We have carbon, which is solid, we have sulfur, which is a gas here, and then we have carbon disulfate here, carbon disulfide, in fact, carbon disulfide. All right, we need to identify something here. We are given our enthalpy change as what? Change in H is greater than what? Than 0. Change in H is greater than 0. Now, what should we know about this is that the forward reaction is what? Is endothermic. And then this would mean that the reverse reaction is what? Is exothermic. The reverse reaction is what? Is exothermic. So we know that if it was change in H less than 0, the forward was going to be exo, the reverse was going to be endo. The system now reaches equilibrium at temperature T. We are given our volume here, what? As 2 cubic decimeter, which was in a container. All right, the Kc value is given as 9,4 at temperature T. So we are given our Kc value here, 6.1. What are we supposed to do here? It says state Le Chatelier's principle. So we are looking at Le Chatelier's principle here. State Le Chatelier's principle for 2 marks. How do we then state Le Chatelier's principle? We come and say when the equilibrium in a closed system, all right, when equilibrium in a closed system is disturbed, it is disturbed. If it is disturbed here, in fact, I can just fix my D there. It is disturbed. If it is disturbed, what then happens? The system here, the system will reinstate a new equilibrium. It will reinstate a new equilibrium. What will happen to this new equilibrium? By favoring the reaction, that will cancel or oppose, let us use oppose, that will oppose the what? The disturbance. That will oppose the disturbance. Okay, that's how you state the Chatelier's principle, that when the equilibrium in a closed system is disturbed, the system will reinstate a new equilibrium by favoring the reaction that will oppose the what? The disturbance. Let us move now to question 6.2. At equilibrium, 1 mole of carbon disulfide, which is CS2, is present in the container. So we are given 1 mole. We are told to calculate the concentration of what? Of sulfur present at what? At equilibrium. So what do we have here? We have our Kc. So our Kc will be equal to the concentration of the product over the concentration of the reactants. Our product here was CS2, and then the reactant here was what? Was sulfur. Remember, we don't include solids in our Kc, sulfur, and therefore it's squared here because it was 2 there. Let us go verify with our what? With our balanced equation. So it was 2 here, this 2 becomes a square. We don't include the solid. These were the what? Were the products. Let us go check now if we are given values. Kc was given as 9,4. Kc was 9,4 equal to, now this was given as 1. This was 1 what? 1 mole. But if you are looking for the concentration, we'll say C equal to N over V, and therefore 1 over, the volume was given as 2. This becomes what? 0,5. So we are going to include 0,5 here. All right, over what? Over the concentration of what? Of sulfur. The concentration of sulfur. All right, this is the same as 9,4 concentration of sulfur, which is squared, don't forget that, equal to 0,5. We go to our calculator now. We divide both sides by what? By 9,4. 9,4. So we are going to have 9,4, in fact 0,5, 0,5, we divide by 9,4. What do we then get here? We have 0,53, 0,5319, 0,5391, 0,53, in fact 0,053, 0,053. So we have S, which is squared, the concentration of that, okay? The concentration of that, which is squared, we can just put it like this here and say the concentration of that, which is squared, is the same as 0,053. What is the square root of 0,053? So we're looking for the square root of that. The square root of 0,053, square root of 0,053, in fact, square root of 0,053. What do we then get here? 0,023, in fact 0,23. We have 0,23. So the concentration of sulfur, that's what we're looking for, is 0,23, which is what? Is mole per cubic decimeter. Okay, that's how you're supposed to get your answer. Do not use the 1 here because the 1 was the number of moles. You have to divide by the volume there to get 0,5, which you're going to plug in here because it is the concentration. Let us move to the next question now. The volume of the container is now doubled. We are now doubling the what there? The volume there at temperature T. After a while, a new equilibrium is now established. How will, this is 6.3 now, how will the amount of Sg change as the new equilibrium is established? We must choose from increase, decrease, and what? And remain the same. Let us check now what happens if we increase the what there, the volume. We are doing what? We are decreasing the pressure. And we know that if we decrease the pressure, we are going to favor the reaction that produces a greater number of moles. So we are going to check now which one produces a greater number of what? Of moles from our equation there. So we can see that this one produces a what? A greater number of moles. We are talking about pressure, we don't include solids, so it's 2 here. So meaning that our answer there will be increase. Our answer will be increase because we are asked about what? About sulfur. So our answer will be increase here. So it's going to increase. Why is it increase? I'm sure the examiner would want us to give a reason in the next question. Explain the answer to question 6.3 in terms of Le Chatelier's principle. So we need to explain now. What do we know? We know that increasing the volume, we know that when we increase, in fact, increasing the volume, increasing the what? The volume. What happens now if we increase the volume? Increasing the volume will decrease the pressure. Will decrease the pressure. Will decrease the pressure. Okay, that will decrease the pressure. And then what is the next bullet here? The reaction that produces a greater number of moles will be favored. So the reaction that produces a greater number of moles, or amount of gas moles is favored. As we have seen there in our equation, it means that the reverse reaction is favored. That's the last question we do there. The reverse reaction is favored. The reverse reaction is what? Is favored. The reverse reaction is favored. You get your 3 marks now. The first thing you must say here, increasing. In fact, something is wrong here. We have an A somewhere here. Increasing the volume will decrease the pressure. The reaction that produces a greater number of moles will be favored. And which is the what now there? The reverse reaction. You get your 3 marks there. Let's move to the next question. 6.5. In 6.5, what are we given here? 6.5. It says in the concentration, if the concentration of carbon disulfide changes by X mole, we are told this one will change by X mole. Write down the expression for the equilibrium constant Kc in terms of X. We are told to show all our workings. We must not simplify, or solving for X is required. All right. Where do we then start? We must then go to our table. We must go to our table here and see if we can get the expression of Kc in terms of X. Let's go to our table now. In our table, we can say that we have initial concentration. We have initial concentration. So we have initial concentration here. What else do we have? We have the change in concentration. We have the change in what? In concentration. Okay. Change in concentration. We also have the equilibrium concentration. So we also have the equilibrium concentration. In fact, equilibrium. I'm missing an I there. Equilibrium concentration. Okay. So we have this table here. We have this table here. So from our table here, we can say that what do we have this side? We can just help here to remove that so that it's in line. We have sulfur and carbon sulfide. So we have sulfur and what? And carbon sulfide, CS2. All right. Now, do we know the initial number of moles? Do we know the initial concentration of sulfur? Now, sulfur in our calculations, we got that there, the concentration was 0.2 what? 0.23. 0.23. And then for C S2, the concentration was 0.5. But remember now that C equal to N over V, the volume was what? Was doubled, meaning this is going to be what? It's going to be halved. So I'll divide by 2 here, I'll divide by 2 here. What do we then get? If we say 0.23 divided by 2, we go to our calculator. 0.23, 0.23, we divide that by what? By 2. What are we going to get there? We are going to get 0.115. So we have here 0.115. Okay. And then for this one here, 0.5 divided by 2. 0.5 divided by 2. What are we going to get? 0.5 divided by 2. We come here and say 0.5 divided by 2. What are we going to get there? We are going to get 0.25. So I have 0.25. Okay. So meaning that I will have 0.25. Now change in concentration, the change in concentration, we were told here that it changes by X. So we go and look at our mole ratio. The ratio is 2:1. So it's going to be 2X here. This one will be what will become an X here. Okay. And therefore from this block here, we are going to have the equilibrium now. It will be 0. I must add it now. 0.115, which will be plus 2X. and therefore here I have 0, comma, the product I must minus, comma, 25 minus what? Minus x, because my product now is now the reactant. They are going to be used up. Let us go to our Kc expression now. Kc expression, Kc equal to the product over reactants. We know that CS2, all right, and then sulfur, product over reactant. My sulfur now is S here, and therefore we have squared. What do we then have now? We have our Kc as what? As 9,4 equal to, we have 0,5 for the product, 0,25 minus x over 0, in fact not 0,25, it's supposed to be 0,11, which is 5 plus 2x. It's going to be what is going to be squared, and therefore that's how I would express my Kc in terms of what? In terms of x. All right, let us look at 6.6. 6.6, the reaction rate time graph below, it represents further changes made to the equilibrium mixture. The volume of the container was not changed this time, it was kept constant. Let us look at our graph here. We are given that the dotted lines will be what will be the reverse reaction, and the visible line here, it will be what? It will be the forward what? Reaction. All right, we are given the reaction rate this side, and we are given the time on the x-axis. What do the parallel lines between TA and TB represent? So this is TA and what? And TB, the parallel lines here. What do they represent? They represent that the rate of the forward and the reverse reaction are equal. So we can say that the rate of forward and reverse are equal. Reverse what? Reactions are what? Are equal. Are equal. So they are equal here. It represents that the rate of forward reaction and the reverse reactions are what? Are equal. That's how you get your 1 mark there. Those parallel lines will indicate that the rate of reverse and forward are what? Are equal. 6.2, it says what changes or what change was made to the equilibrium mixture at B. Let us look at B now. Let us look at B. Now this is B. We can see a sudden increase from what? From B. So once you see a sudden increase, it means that concentration was what was affected there. Because you can use an example of water and orange juice. Immediately you pour water into the orange juice, it changes color. So you see the change immediately here. That is what? That is concentration. So we can come and say concentration or increase in the amount of what? Of concentration. So there was a what? There was an increase in what? In the amount. Amount of what? Amount of sulfur, or you can say what? Or concentration. All right, you get your 1 mark there. Let us go to 6.3. 6.6.3. They said give a reason for a sudden change at reaction rate what? At TC. Let us look at TC. TC is here. There is a sudden change as well at TC, but both the reverse and the forward will do what? Will decrease. Will decrease. What causes that? It means we had what here? We had a decrease in temperature. We had a decrease in temperature. So we had a what? A decrease in temperature. A decrease in what? In temperature. We had a decrease in what there? In temperature. I'm sure the examiner is going to ask us why or give a reason for your answer there. That's when you're going to explain using the Chatelier's principle there. It says fully explain the answer in 6.6.3. All right. What do we notice here? We notice that the rate of the forward and the reverse reaction decreases. I'm sure you have seen that the